Bond parameters is one of the important concept under chemical bonding. And here we have different types of bond parameters: bond angle, bond length, bond order, and these are the important things. And out of these things, we already discussed bond order in last class. Now in this class we are going to discuss a few things related to bond length and bond angle. Before discussing the questions on bond angle, first we will know the basic things, something like what is the bond angle in case of linear molecule, and what is the bond angle in case of trigonal planar structures, what is the bond angle in tetrahedral. And see here, in case of linear structures, the bond angle is 180 degrees. What is bond angle here? The bond angle is nothing but the angle between the two side atoms with respect to the central atom. In case of linear, it is 180 degrees, and in case of trigonal planar, it is 120 degrees, and in case of tetrahedral, it is 109 degrees and 28 minutes. And now we will calculate a few on these bond angles. Let us start with first one. An element M reacts with chlorine to form a compound X. The bond angle in X is 120 degrees. What is M here? Option A, beryllium. Option B, boron. Option C, magnesium. Option D, nitrogen. In the given question, the element is M. And see here, they given it reacts with chlorine and it gives one compound, and that compound has a bond angle 120 degrees. See here, 120 degrees in the sense it should be a trigonal planar. Trigonal planar. Trigonal planar in the sense three chlorines will be as three side atoms, and M will be the central one. And see here, these things possible in case of third A group elements. Third A group elements can form trigonal planar structures with halogens. From the given options, which one is the third A group element? Boron is the third A group element. Okay, and see here they given beryllium, boron, magnesium and nitrogen. Out of all these things, boron is the third A group element. Then answer is boron. Sometimes they will give other things also. Something like boron trifluoride. Okay, and here this is nothing but boron chloride, BCl3. Okay, and the option is boron. In the second question, we will check the order of bond length. Please note down it. The correct order of C2C bond length is in the given options. Once you check it, we have acetylene, we have ethene, we have benzene, and we have ethane. See here, in all the options they gave same things but in different order. We will check it. C2H2. See here, in case of C2H2, carbon has a triple bond. Carbon has triple bond. And in case of C2H4, we have double bond between two carbons because it is alkane. Now C6H6, here if you observe that one, we have alternate double bonds. We have alternate double bonds. And in case of C2H6, we have carbon single bond. And here you have to learn one important point. More the number of bonds, less will be the bond length. Reason, if number of bonds increases, its bond order will increase, and its stability will increase, and its bond length will decrease. Number of bonds and bond length are reciprocal to each other. Based on that point, we can write the correct order for bond length. See here, now here it has more bond length, and then here it has alternate double bonds. All are not double bonds, alternate double bonds. Here it has only double bond and here triple bond. Now then the order is CC single bond has more bond length, and then alternate double bonds, and then double bond, and then triple bond. Okay, this is the correct order for bond length. And in case of bond order, it is just a reverse. It has more bond order. Next this one, and then CC single bond. Now they are asking the correct order of C2C bond length. Then answer is option A is correct answer. Let us check one question on bond angle. Bond angle is minimum in option A, NH3, option B, PH3, option C, ASH3, option D, SBH3. They are asking which one has a minimum bond angle. If we check the options, there is one interesting thing, that is all the side atoms are hydrogens and all the central atoms belongs to same group. See here, nitrogen, phosphorus, arsenic, antimony, they belongs to 50th group. And here the electronegativity decreases from top to bottom. What is the relation between electronegativity and bond angle here? Very important point. If the electronegativity of central atom decreases from top to bottom, its bond angle also will decrease from top to bottom. Bond angle decreases with the decrease in the electronegativity of central atom. Fine. When it has same side atoms, the bond angle decreases with a decrease in the electronegativity of central atom. That is very important point here. And here in this one, which one has least bond angle? Stibbium hydride. And here I will give one more example which is reverse to that one. When it has different side atoms and it has same central atom, then what is the condition? See here, let us take one example. We will take OF2 and OCl2. Here if you observe this one, the central atom oxygen is the same. Oxygen is same. And here side atoms are fluorine and chlorine. Fluorine and chlorine belongs to which group? 7th group. And here electronegativity decreases from top to bottom. Fluorine has more electronegativity, chlorine has less electronegativity. And here the bond angle in case of OF2 is 103 degrees and here it is 111 degrees. What you observed here, if central atom is same and if side atoms are different, the bond angle increases with a decrease in electronegativity. Just reverse to that one. Bond angle increases with a decrease in electronegativity of side atom. Here bond angle decreases with decrease in electronegativity of central atom, and here central atom is same, side atoms are different. That's why here bond angle increases with a decrease in electronegativity of side atom. And it is very important one. Please note down, sometimes they will ask this one, sometimes they will ask this one. And especially in JEE and NEET exams, they will not ask direct bond angles. They will ask with respect to the properties, something like electronegativity and different things. Okay, please note down this one. Check the fourth one. Higher the bond order, greater is the option A, bond dissociation energy, option B, bond length, option C, paramagnetism, option D, ionic character. In the given question, they are asking indirectly which one is proportional to the bond order. And see here, you have to know few points. Bond order is proportional to number of bonds. Bond order is proportional to number of bonds. And it is also proportional to stability. Stability of the bonds, or you can say stability of the molecule. and see here, and it is reciprocal to bond length. Reciprocal to bond length. And more the bond order, more will be the number of bonds and more will be the stability. As a result, the bond dissociation energy is also proportional. It is proportional to bond dissociation energy. What is meant by bond dissociation energy? Bond dissociation energy is nothing but the energy required to break the bond between the bonded atoms. And see here, if it has more bond order, it has more stability. As a result, we require more energy to break the bond. That's why bond dissociation energy is also more. And here there is no direct relation between bond order and paramagnetism, or you can say bond order and ionic character. And in the given option, they gave bond dissociation energy and bond length. Bond length is reciprocal to bond order. That's why I mentioned this one also here. And here they are asking higher the bond order and greater is the, means proportional. Which one is proportional? Bond dissociation energy is proportional here. Okay. And answer is bond dissociation energy. Option A is the correct answer.